We are going to be moving out of a lot of math talk and into some more actual chemistry talk. So, video number 13 is all about classifying different types of matter. So, a bunch of definitions and some things that we need to talk about in this video. Your objectives are twofold. One, you should be able to define what matter is and classify whether it's an element, a compound, or a mixture. Then you should be able to classify mixtures as either homogeneous or heterogeneous mixtures. So, first let's talk about what matter is. Matter is basically anything that takes up space, which means it has a volume and has mass. So, anything with volume, anything with mass is classified as matter. There are a couple different types of matter. The first type is a substance. A substance has a uniform and definite composition. So all throughout, it is all the same. There are two types of substances. The first is an element. Elements are the simplest form. They can't be broken down, and they are listed in your table S that we looked at with the density lab, but also these are what's on the periodic table. Obviously, periodic table of the elements. So elements are all those things that are listed on the periodic table. Compounds are two or more elements that are chemically combined in a fixed ratio. Like water, H2O, is combined two elements, hydrogen and oxygen, in a fixed ratio, 2 parts hydrogen to 1 part oxygen. So water is a compound. So to tell the difference between elements or compounds, use table S or look on the periodic table to determine if they can be broken down into smaller substances. So take a minute, pause the video if you need to, look at these and decide if they are elements or compounds. Iron is an element. Its symbol is Fe. It can be found on the periodic table. Copper is also an element. Hydrogen is also an element, even though there's two of them stuck together. There's only one type, hydrogen. There's nothing else. Water, we talked about already. It's a compound. It's got hydrogen and oxygen. Sugar is also a compound. Carbon, hydrogen, and oxygen in a fixed ratio. Oxygen is an element. Salt is a compound. Sodium and chlorine is the most common type of salt. So it's made up of two elements. And then calcium is an element. You can find that on the periodic table. Ca is its abbreviation. The next type of a substance we want to talk about is a mixture. Now, a mixture is made up of two or more substances. They're not chemically bonded together, and for the most part, they can be separated. So there's two types of mixtures. There's a homogeneous mixture, which is uniform all the way throughout. You cannot see the different parts of it. Sometimes in chemistry, you'll see it has the symbol AQ after it, which just means it's been dissolved in water. A good, easy example of a homogeneous mixture is maybe a sweet tea or coffee. So sweet tea is mixed together, tea and sugar, but it's uniform. You cannot see the sugar versus the tea. You can't separate them out. The same with coffee. If you have sugar and cream in it, if you look at the cup, it all looks the same. You can't tell the difference between the cream and the coffee. Now, a heterogeneous mixture is not uniform. You can tell the different parts. Beef stew is a good example of this if we want to stick with the food example. You can see the potatoes, the carrots, the beef, the liquid. You can see all the different parts. So it's not uniform. A chocolate chip muffin is another good one. You can see the chocolate chips. You can see the muffin. It's a heterogeneous mixture. Oops, take a second, look at these, tell me what you think. Decide if they're homogeneous or heterogeneous. So the chocolate chip cookie is obviously heterogeneous. You can see the different parts. Milk is homogeneous. You can't tell the fat from the milk, from the water, from the different parts. Um, and then I'm not even sure what this is, to be honest with you, but it looks, I don't know. You tell me. Send me an email. Tell me what you think. We'll take a vote. So when we talk about mixtures, whether they're heterogeneous or homogeneous, they basically have two parts. Solute is the substance that is dissolving. So with our sweet tea example, that would be the sugar. And the solvent is what it is dissolved in. So that would be the tea. So solute would be the sugar, solvent would be the tea. Um, and the sugar is dissolved in the tea. Now, what is the universal solvent? There is a liquid called the universal solvent. Try and figure it out. Bring me a little slip of paper with the answer written on it and your name, and I'll give you some extra credit. So take a minute, pause the video, just really quickly go through these things. Determine whether you think they're element, compound, or mixture. And if they are a mixture, are they homogeneous or heterogeneous? So just take a minute and figure those out. Okay, I'm not going to go over the answers, but let me know if you have any questions on what those are. So, quick little summary. If there is a single chemical symbol with one capital letter, that's an element, whether it's just the H for hydrogen or the capital N with the lowercase e for neon, only one capital letter, that makes it an element. If there are two or more symbols with two or more capital letters, that will be a compound. All elements, all compounds are homogeneous, so that's important to remember. If there's not a chemical formula or there's not a fixed ratio, it's a mixture. And we can have homogeneous or heterogeneous mixtures depending on whether you can see the different parts or whether it's mixed together uniformly. Hopefully now you should be able to tell the difference between an element, a compound, and the two types of mixture.